keep this for homework as well. I want to slowly get into the bit of the sine cos. Maybe as a practice, can you try the 35, 36, and the 37? So a bit of the circular functions. If you know your own method, and these questions are tech-free, so please don't use the CAS. What's the plan for the first one? And also these ones, are you memorize all the exact values in different ways? I don't mind which way, or triangles, or any method. But if I ask randomly, you should know exactly what's your values. If you're still not, so you hurry up and try to memorize somehow. Now, sine 210, which quadrant? That's going to be third quadrant, be somewhere here. And then what's going to be this tiny little angle here? What's the answer? 180 minus 180 from this one, you get the 30, isn't it? That's 30. I don't know which method you try. If you know any method, and you can get the answer. I don't get the answer for this. I just write one method anyway, which is in the third quadrant, how do you get the answers? Sine 180 plus 30. Sine in the third quadrant, positive or negative? That's going to be positive or negative? Negative, isn't it? Because third quadrant sine negative. So negative sine. So my technique is usually I forget about the 180, forget about the sign, just grab the number and place it here. So answer is negative sine 30, which is negative half. Done. And 36. Easy question, but sometimes when you're looking at it, you feel confused. Brian, what's the plan for looking at the 36? How do you approach? And these are also text-free. You add them? Yeah, you can add them if you want to get the question complex. Do you want to make your question complex?
No.
Okay, don't add them. What's next? Anything else that you can think of? Only thing you didn't notice here, it's pi over 2, special one. What's pi over 2 means? 90. I think we explained something about 180 and the 360 being used. Then don't change the sign cos tan. But if you're using 90 or 270, sign becomes cos. Cos becomes sine. Tan becomes 1 over tan. So this is what I'm talking about. Using 90 or 270 in the questions. Sine becomes cos. Cos becomes sine. Tan becomes 1 over tan. Otherwise, the same method as this one. So this is acting as a 90. So Ren, pi over 2 plus pi over 6. Which quadrant? Hmm? 90 plus pi over 2. Which quadrant?
The second.
Second quadrant. Second quadrant, tan positive or negative?
Negative.
Negative. And then negative, but don't write the tan. This becomes 1 over tan. The reason we are using the 90 degrees. So 1 over tan, what I said before, just write the answer, pi over 6. See, that's a method. Negative 1 over, what's your tan pi over 6?
Root 3.
Pi over 6? 1 over root 3.
Oh, yeah.
Tan 30, eh? So 1 over root 3. So you can just rewrite the answer as is negative root 3.
Wait, so how is that easier than just adding it up?
If you add them up, what do you end up getting?
Well, if you translate it to like degrees, it's just gonna give me 10, 120. Then you can just do 10, 180 minus 60, and
Yep.
then find 10, 60 and make it negative.
Yeah, for this question, I reckon we can do it easily in that way as well, isn't it?
Yeah.
Yeah, but not every question. Yeah.
Okay.
Good to know this method. Yeah, I think this particular question, yeah, you can do both ways, sort of very similar sort of steps. But there are certain questions we good to know the method. The reason, some questions they're more symbolic. Example, you can get a question like this one. Maybe sine pi over 2 minus theta. Then you get confused. You don't know where to go. Yeah. And I think we got some questions like that somewhere here, maybe. Did I put anything there? Like these sort of questions with the pi over 2. Yeah. So good to know the technique because there are some questions with bit more symbolic form. Cool. But both methods are fine as is negative root 3. And I'm going to ask you to do maybe question number 37. Question 37.
No calculator, right?
No calculator. These are all text-free questions at this stage. What's the plan? Very similar technique. Only thing is it says 3 pi. Just see the location. Because sometimes we do like few rotations. It doesn't really matter how many you do. We just need to figure out which quadrant we are in. Example, 3 pi. That's 3 pi. See, from there to there is going to be pi. And now it's going to be 2 pi. Now it's going to be 3 pi. See, I'm stopped at that point. So 3 pi, take away pi. Which quadrant? Here on the second quadrant. See, it doesn't matter how many cycles you go over. Just see what's the actual location. So which is, I can rewrite or redraw my graph. It's somewhere here. See? And this is exactly same as now sine pi minus x. Is that true? But that's the location of that. It doesn't matter if you go 3 pi, 5 pi, 7 pi, you're on the same location. All right, sine pi minus 6. So, general, which quadrant we are in?
Second.
Second quadrant, sine positive or negative?
Positive.
Positive. And do we keep sine as sine or do we change it to cos?
Keep it as sine.
Keep it as sine because pi means the 180, not 9, isn't it?
Yeah.
And then just x. What's the answer for sine x?
0.6.
0.6. So answer is positive 0.6. Done. So that's the method. Can you try the part B? Any questions?
Is part B just 0.8?
0.8. Why? 4 pi means you go 2 full cycles going back to the origin, isn't it?
Yeah.
Exactly. See, like this is 2 pi. That's 4 pi and then plus x. You are here. So as is simply 0.8. See, these are easy questions just to understand how to approach. So answer is 0.8. All right, this question you can, let's see whether it's sum of the solutions between 0 to 2 pi sine 3x equals to cos 3x. Are you all happy? You know how to solve the tricky equations? You want to try one question maybe? Just this one? All of you? All right, this is tech-free as well. So we need to find all the solutions between 0 to 2 pi. 0 to 2 pi. So hurry. Shall we do it together? Yeah? Ready?
Yeah.
Okay, cool. What's the first thing we do here then? Because you have the sine and cos both, so you can't really work anything out yet. This is a very common type of question. So you divide both sides by cos 3x. You divide both sides by cos 3x. So end up getting sine or cos becomes tan. That's why answer is getting tan 3x is equals to just 1. Harry, what's your reference angle? Tan something is 1. Pi over 4, isn't it? Pi over 4. Which quadrants? Tan positive. First hand? First hand?
Oh, 3.
Third, isn't it? Good. And then let's get the answers. The first answer is just pi over 4. The second answer is, how do you get the answer in third quadrant? Pi plus pi over 4, which is 5 pi over 4, isn't it?
5, 5. Yeah.
Perfect. So you got two answers. So don't forget these two answers for 3x. See, this is something that we keep forgetting. If this is 3x, that's going to be 3x. And then find the x. What are the x values? Divide by 3.
Pi over 12 and 5 pi over 12.
Pi over 12 and the 5 pi over 12. Sounds good. And then what's the next step? We need to write down the domain. What's the domain?
Can we adjust the
0 to 2 pi.
domain?
But so doesn't the domain increase? Because
Just 24
you don't
pi.
need to increase the domain because we just found the answers for x. Emma, yeah?
because we found 3x
we
and
found the x already.
yeah, but
So can we
wait,
add-
like for the other general equations, you go like all the way, like 2 pi becomes 6 pi.
Yeah.
Yeah, so if you find the x, you don't have to change the x. Why? This is for x, we found the x. Does that make sense? But if you keep the 3x, then you need to change the domain into 3x as well. But the best way is find the x till the end. You found the x now, two values, and then based on that, keep the domain as it is. The only change I do here, can you see two of my answers have what's your denominator?
12.
Oh.
So can we just
12.
adjust?
So yeah, just like multiply and divide the domain by 12 just to see things easier. So my answer is 0. Then this is still x. This
Then
is
24.
24x pi over 12. Now, look at the two answers we just found. Are they within the domain or not?
They're within the domain.
They're within domain, right? So two answers are perfectly fine. How do you find more answers?
Wasn't it plus or minus
Plus or minus the period for the question. Okay. So plus or minus the period. For this question, what's the period? Pi over 3. Perfect. Pi over 3. So we plussing or minusing the pi over 3. I don't think there's no point of minusing in a way because we don't have negative values. And also try to make it simple. Can you see that both answers are over 12? Can you change this as well to over 12? So much easier in the question, which is times by 4, isn't it? See, 4 pi over 12. So all you have to do is just adding or minusing 4 pi over 12 to the answers. Let's try the first one, okay?
Yep.
I'll grab the first answer, which is pi over 12. Add 4 pi over 12. What's the answer?
5 pi. Oh, we already got that.
You already had the answer because we know that little trick for the tan, answers are repeating.
Yeah.
So nothing to worry about doing both, just pick one and do it. Which is I'll grab the 5 pi over 12 in that case, plus 4 pi over 12. What's the answer?
9 pi and 12.
That's the answer. Perfect.
We can't continue.
And then again, 9 pi over 12 plus 4 pi over 12. What's the answer?
13, which is outside the domain.
13 pi over 12. No, still within.
Yeah, bye.
Yeah, still within. So that's fine. And do more. 13 pi over 12 plus 4 pi over 12. Which is? 17 pi over 12 still within multiple answers. And then 17 pi over 12 plus, what is it? 4 pi over 12, which is 21 pi over 12. Still within. Maybe you can't do anymore. Yeah. That's all. How many answers you got? How many? 5
5,
or
yeah,
6? 6, isn't it?
Yeah. Wait, what? Oh yeah, with the 20.
1, 2. Yeah, 6 answers, even this one as well.
Yeah.
All right, so all the circled answers are the answers. Harry, is that what they're asking?
Oh, it is something added up. To
Yeah, so don't forget, I think this question is very common. Most of them got the answers, they just walk away without adding them. Yeah, so be careful. Add them up and then get the final answer. Yeah, always like keep one good question in the bound book, maybe try, even like for exam practice, keep 1 or 2 good questions of every section. And once you practice that, you can recap the whole lot. Rather than doing like maybe 10 of the simple questions, keep one of the good questions.
This is tech free, right, sir?
This is tech free. Yeah, you can get tech active, but you can do either way. But this particular one, tech free. Sonika, do you try the same method? Did you do the usually same method? Or differently?
We usually like to change the domain first, but
Into
yeah.
2, 3x or something, yeah? Yeah, that's fine. In that method, but I realize, sometimes rather than 3x, they probably give you just example, maybe this one. Like example, I don't know, something like this. Then this is massive. So then you have to change the domain into that. Isn't it? Like then your steps getting pretty longer. But if you find the x by itself, and the rest gonna be easier. They're both methods gonna work, but if you get a question like this form, then your steps gonna be longer. You're spending another extra probably 4 or 5 minutes on top of that. Yeah.
Yeah.
Yeah, try to get used to it. And the best way to get used to it is try the same question with both methods. And see if you can get the same answers at the end. Maybe try 2 or 3 questions with the same method. Then you realize the amount of the work you do. But when you try it, try something easy one first with both methods. Make sure you get the same answer before that. And then try something tricky as possible with both methods. Then compare it and see the amount of time you spend or maybe the steps you have. Then you realize, yeah.
How many marks is this one again?
Ooh, this one probably get 2 to 3. Because you need to find the answers, you have to add them up. Yeah, so
most people got 2, right? Because they didn't add up the.
exactly.
Okay.
Are we all good? Answer, I'm not worried about the answer. It's 11 pi over 2. Answers are fine. As long as you get the method, that's the main idea.
Yeah, 11 pi on 2.
Cool. I believe all of you memorized these rules. Yes? They're easy. But I think the most confusing one for most of them is this one. For some reason, they keep forgetting it. Don't know why. Keep forgetting it. But all I can say, you need that for the general solutions. Because the previous method, you can find the solutions, but you can't find general solution. But this method, you can find general solutions as well as the actual solutions. Shall we try one question just to break up the memory?
Okay.
Find the general solution for root 2 cos x minus 1 equals 0. Now, for this one, can you rearrange, please? Which is cos x is equals to 1 over root 2. Same as before. What's your reference angle? Pi over 4, isn't it? Pi over 4. And then once we do that, then we need the cos. We got two equations. X is equals to 2n pi plus, see here, cos inverse A, sin inverse A, or cos inverse. This section is your reference angle, which is, in this case, pi over 4. So replace that with pi over 4. Oh, good, yeah. X is equals to 2n pi minus pi over 4. We got two equations. Can we simplify? Get the common denominator. 8n pi plus pi over 4, or 8n pi minus pi over 4. So we found the two answers, and this is what we call the general solutions. That's the general solutions. And don't forget right at the end, n is the element of z. You should write that to get the full marks. What z means? Integers. It only sub n values as the positive or negative whole numbers, including 0. Perfect. So that's the first part of the question. Then it says, hence find all the solutions for the x within that given domain. Write the domain here, so which is negative 2 pi to 2 pi. How do you find the answer? Keep subbing the values. All you have to do is sub n equals, I'll sub the positive values first. N equals 0. What's the first answer? In the first equation, make n equals 0. What's the answer? Just positive pi over 4. And this one, x is equals to negative pi over 4. And then, can you select all the answers we are getting over 4? So best thing is, change the domain to cater the
Can you use
4.
the reference angle? Change it.
Reference angle changes.
Should work.
Why is that?
Like using the reference angle, we can just change the domain. Is that okay? Or
That's
that?
fine. Yeah,
Okay.
that's fine. So what's the answer here? Negative 8 pi over 4, and this is positive 8 pi over 4. So you can clearly see, how about the both answers you found so far? Are they within the domain?
Yeah.
They are within the domain. Perfect. Then try the n equals 1. We keep doing this process until you're not getting answers within the given domain. How about the next one? N equals 1. So 9 pi over?
That's out of
Well, that's out. Next one?
and
7 pi over 4. That's in.
domain. Yeah.
I don't think doing any more in that one. Yeah, so no point. Maybe try the negative side. N equals negative 1. Just work it out, all of you.
Yeah.
That's the method. If they only ask general solutions, first part is enough. Because to find all the solutions, they have to mention the domain. Otherwise, we always can find the general solution. Is that clear, all of you, the technique? You have done them before. I'm just trying to recap one question.
Yeah.
At least if you realize if you this is something hard or something, go back and do some questions. And that's the whole idea.
This is more like a common tech-free like questions, right?
Also multiple choice. You get
Oh
that.
yeah.
Yeah. If it's multiple choice, just use the CAS. Just solve the equation without putting the domain. So you get the general solution. Yeah.
Yeah, negative 7 pi on 4.
Negative 7 pi over 4. Yep.
Yeah, that's it for that one.
That's all, isn't it? So how many answers altogether?
3. Oh wait, 4.
4 answers, eh? X is equal to negative 7 pi over 4. So answers are this one, that one, and that one. So
Yep.
4 answers. I mean, all of you know how to solve this by CAS, isn't it? Just type the equation. And if you're using the sine costan, you should put the domain.
Can we just say plus and minus pi on 4? Is that okay?
That's fine. That's fine. Yeah, no issues. All right, perfect. Let's move on to some other questions. Yes, general solutions. I just put one of them just to remind you. How do you write the general solution or general equation for the sine? Y equals A sine n bracket x minus b plus c. Just in case if we forgot, because we need the n value to find the period. And this n can be a whole number, can be a fraction, can be a number with the x. So this whole thing, anything you have in between sine and the x will be your n. So be careful. Sometimes, the questions you get may be this way. And sometimes you feel like, oh, maybe n is 1. No, really. What's the n value? What's the n value? Anyone? So n is
1/4.
1/4, exactly. See, there's a hidden 1 there and 4 at the bottom.
Okay.
So that's why n is equal to 1/4. So you can't see sometimes. Be careful. All right, the next one is sketching the graph. Let's see. That particular question is not bad. You can do it for homework, okay? 41 homework. And maybe I want you to go through this question, 42. It's something that you should know. Read, and this is also tech-free. Read, if you know the technique or how to start, just let me know. I'll give you a minute just to get the idea. Anyway, just openly answer it, and if anything wrong, we'll fix it. And math is, don't afraid to try things. Try different things, just if you're not doing anything, you don't try it, which is no point. Any suggestions? Yep.
Can we move one of the sine over to make it tan? Like, no, sorry, wrong words.
You mean divide the cos
yeah,
by cos?
so it becomes
Yeah,
tan.
you can do that. Then you end up having one of the signs left out and also tan there,
Oh, then
isn't
it's
it?
too complex.
Like, again, you can't. Because these questions, either you turn them into all of them sine, all cos, all tan. Yep.
Mister, I did one similar question, but I don't exactly remember. What was like sine squared of x? Was that 1 over sec squared, like something like that? I don't exactly remember.
I mean, yeah, the 1 over sine is same as the cosec. But the problem is, even if you make it cosec, then again, bit more complex, isn't it?
Yeah.
Yeah. I mean, that's good. I mean, it's all about trying it, as I said. So that's one way, but then you realize, hang on, what's the cosec? Then you can't use the cosec in this particular question. There are some questions you can, but try again. Try again. Any other options? Anything else anyone feels like to try? Something easy, something easy. Once I write the next step, you know that, oh, I know the method. That's how you feel. But you should have tried that before I tell. As I said, when you're doing these questions, either you have to make them only sine, only cos, or maybe only tan. Because keeping cos and the sine, you can't do much. The only thing that you forgot is this equation. What's the answer for this?
That was
That's a
all
one.
thing.
Yeah, that's exactly what. This is the, what is this? This is the identity.
Yeah.
You have to make it 1 over, it's actually take away. See, what I can do, I'll take this to the other side, becomes 1 minus cos squared x. Does that make sense? So 1 minus cos squared x. And then simply we can replace that whole sine squared x with the 1 minus cos squared x, isn't it? At this stage, do you have sign? No sign, only the cos. Expand fully, take everything into one side. Now let's give it a try. 3 cos x is equals to 2 minus 2 cos squared x. I'll take everything into left-hand side, which is 2 cos squared x plus 3 cos x minus 2 equal. What does it look like?
Like a almost a
Like a
quadratic.
quadratic, yeah. So you can factorize. Even you can just call them as maybe, I can say, let a is equals to cos x.
Yeah.
Just 2a squared plus 3a minus 2 equals 0. Can you please factorize it, all of you, and tell me the answers, or tell me the factors. See, from there onwards, not too bad, but still like we're halfway through the question though, not fully done. Tell me the factors, anyone? I'm gonna first with the factorizing. I believe you know what to do factors there. So 2a minus 1 and then a plus 2. If you think you need to factorize or you need to revise that, just make sure to do some more questions. Factorizing, which is chapter for the quadratic. Now, answers are a is equals to half.
And a equals -2.
Perfect. And then we can't keep the a though. We need to put back our cos x to the question, which just becomes cos x is equals to positive half or cos x is equals to -2. This is the place we start the question. See, cos x equal half, you need to do all the steps now, like the reference angle, quadrants, and find all the solutions in the given domain. How about the cos x equals -2? What are the reference angles? Anyone? Cos x equals to -2. No as? Tale? Cos x equals -2. What's the reference angle?
You have to reject it because it needs to be between 0 and 1.
Exactly. You should reject that. The reason, the cos, the lowest is -1, highest is 1. But -2 means out of the range for the cos. So literally, this one you can just say no solutions, we're lucky. If it is anything else, you get more answers from that side as well. So literally doing like 2 questions together. And this one, you can do that reference angle, which is pi over, what is it? Pi over 6? Quadrants, no, pi over 2, pi over 3. So pi over 3, and the quadrants for cos positive is first and the fourth. And likewise, find all the answers. So that's the technique. Did you get the method, all of you? And that's the reason I put like whole bunch of more of these questions in this page as well. Can you see? They're very similar. So I think good thing is practice these for homework, this section, and then to double check, use a CAS, and then double check the answers.
Hold on,
Okay.
so could you go back up a second?
Yeah.
How did
Yeah.
Wait, so is sine squared 1 minus cos squared x?
This one?
Yeah.
That's
Oh,
one of the identities on the
you're right. Yeah.
yeah. That's what we call the Pythagorean identity, isn't it?
Yeah.
Good.
Thank you.
You got the method. Yeah, I mean, most of these questions, you can try the same technique. You can just rearrange using those equations. And some questions like this, what's the method? Factorize it. Can you see something common here? I'll quickly explain slightly about number 1, then I'll let you write it down, the steps. At least you can get going for homework. See, in this number 1, is there a common factor in there? What's common? Cos x. So you can take the cos x out. What's in the bracket? Root 2 sin x minus 1 equals 0. Can you see clearly There's two factors you have. Now factor load. One answer is cos x equals 0, or you can rearrange sin x is equals to 1 over root 2. See that? So in this particular question, you got two different sections to find the solutions. Okay, so that's the method. So after this section, and I'm going to give you guys a little break for half an hour. And I'll focus slightly on towards this section, and then I'm going to start doing the calculus part. And the fourth section more towards the probability. Okay, so I think we get in there, but the whole idea is to just understand the concepts and also understand which ones you need to revise. If you realize, hang on, these ones I need a bit more attention, just note that down. So once you finish the webinar, then you can actually work towards that to fix them up. So this one as well. Yeah, so literally like we'll have a break and we'll be reconnecting probably at, so we'll go half an hour, so 12:30. You happy with that? You don't have to disconnect, just stay there and you can reconnect as it is there. I'm going to leave it there and walk around, have some lunch or any food, and then we'll come back at 12:30.